Hello all, Corner Pirate here, and welcome to Intro-ish to SQL Injection. This was delivered live at Glasgow Defcon again in early March 2020, and it was following on from last month where the intro to SQL Injection happened and all these lovely people came and someone took a photograph. I'm aware that there's some of the people that were here on the night in March are going to be watching this as well. So I'd like to try and record it a little bit as if it was the live demonstration, but I won't overly burden the YouTube stream with that. So answer the first question, can I have the slides? Yep, slides, vulnerable content, and a video walkthrough are all available from that GitHub repository, Teaching Moments. That's where I'm going to be uploading things. And essentially last month's were already there, and this is me recording the video now to essentially put a recorded version of this month's in. So that's the URL. We'll see it at the end as well. Okay. So I'm starting off with a little bit of a review, which was available in last month's video. Just a quick reminder of what we meant. So there's a bit of an overview of SQL, a couple of simple examples, but then we just kind of jumped into this month's more advanced demos, shall we say. What is SQL? It stands for Structured Query Language, and some say SQL, and if so, I missed the original. Most hit you with SQL, though, which I think is pretty good. It is the standard language for relational database management systems, according to that quote there. And for me, a database holds information in tables with rows and columns, and I like to think of it as fancy spreadsheets where there's one workbook per table. SQL is the structured query language, and it allows you to insert, modify, read, and delete data from the database. So that's, in a nutshell, what it is. Here's an example table, which we saw last month as well, and it's still the same target this month. This is a table called People. The table name is People. It would be a workbook called People if it was Excel. There are 3 columns and there are 3 rows. And the 3 columns are an ID, which is an auto-incrementing number. It increases as you add rows. The name field is a string data type, and the age is a number. And age is only ever just a number. I would like to remind people of that. Here's the basic SQL syntax. Simple syntax is select column name separated by commas from table name. So that's pretty simple, and then it does get a little bit more advanced as you go down there. You can augment the query to group things, to search whether a condition is true. You can also order things ascending and descending. We'll show a little example of that in a minute. So this is my first ever SQL query. This is baby's first query. He's born into the world with the sun in his eyes, and the baby goes, "Bleh, select star from people." That star is an asterisk, and the asterisk means get me all the columns from the people table. So because the people table has ID, name, and age, it's going to get all 3 columns. And because there's no where clause or anything, you're going to get all 3 rows. So there we go. We have our original source table. No trickery there. That's the original table. 3 columns, 3 rows. Here's what the SQL query returns. 3 columns, 3 rows. Everything's wonderful. So that's the first query. So when baby starts to learn how to walk, they figure out that you can add those where clauses and those order by clauses. So where age is less than 40, and remember age is just a number, it's not important. You can still act disgraceful at my age. Age less than 40, we throw away tab Stafford because his age is greater than 40, so the result set is only going to have 2 rows. We order by age descending, meaning that we're going to count down from the highest number to the lowest number, so that's how it orders it, so that Lila is top and Autry is at the bottom. So that's, in a nutshell, what the simple select statement is going to be. In the first tutorial, we did an awful lot with this union select statement, so it's important to cover this again. Blessed be thy union is what I say when I was doing this live. Select ID, name, age from the table called people. That's this bit here is what we call the left hand side of the query, whereas this bit in yellow is the right hand side of the query. So the important thing is there are 3 columns in the left hand side, meaning that if we're going to do a union select, we're needing to supply 3 columns on the right hand side, or it doesn't work. You will get an error, right? So as long as the left hand side has the same number of columns and the right hand side has the same number of columns, and they're all sort of broadly compatible data types, The result of a union query is to return a table which is the result of the left-hand side added to the back end of with the right-hand side. So effectively, the select ID, name, and age, that's the same as select star from people, is going to get you all the people in the original table. So there they are, all of them again. And then the union select adds in one more row where the values are A, B, and C. So the union select is useful for data extraction. So the whole point of the demos in the first video was pretty much to use the union select statement to extract data. Now, you can go back and review that because I'm not going to do it again. This month the demos are about blind SQL injection. But first, what is SQL injection? It's a vulnerability allowing an attacker to alter the intended logic of an SQL query. That's my little bit there. Alter the intended logic. That is the key bit. So if there's ever a point where an attacker can find a vulnerability and they can manipulate the intended query to return something else, then the chances are you've got an exploitable weakness, and that's the important thing. So it exists where queries are generated dynamically using string concatenation. So here is a line of PHP. The target in these demos is always PHP with a MySQL database backend. So the string SQL is created by using this bit here and then appending this part here, where the underscore get collection is equivalent to this little parameter down here in a URL. So whatever the value in the age parameter in the URL is, it's coming straight in and it's being appended into this string, meaning you probably have SQL injection, and so you should start to look for it. So the key part is that the query is generated dynamically by some user controllable input. So a little bit of a quick recap of the demos from the first one, rather than showing them in full detail. What you had to do is you had to find the number of columns in the left hand side. So to do that, you would break out of the logic of the intended query. You'd use order by n, which is where n is a number, and you'd use the dash to comment out the remaining part of the query so that it removed the error. So in our example, you did order by number 4, it would give you an error. And if you did order by number 3, it would give you no error. So you found the highest number, which doesn't cause an error. Therefore, you've determined how many columns were in the left-hand side. Then you can perform a union select. So union select null, some sort of piece of information, and null, that would return the version number of the database, and that's exactly what the demo showed. That means that you have data extraction because text appeared in the results page. So because the text appeared in the result page, this version got echoed back, we can directly extract text using the union select technique. Now, here's where we go a bit off-piste. Yarr! Here be the monsters, right? So this is where the new demo kicks in, basically. We're really talking about blind SQL injection. So when the site does not return errors, that's what we mean here. When the site does not return errors, where the query returns no HTML content. So in the previous slide, we saw that the active version was echoed back as part of the page. We could use that to do things. Does that mean that we're not vulnerable? Does that mean that as long as the page is just running a query in the back end and literally no data is being rendered to the browser, does that mean we're safe? Of course it doesn't. It's harder to detect and it's hard to exploit, and that's why the demo shows that. So it is possible to do it, and we're going to show you how. So when you're shooting in the dark, what do? Well, first off, you have to look for detectable differences. Does the HTTP status code change when an invalid syntax occurs? Does any part of the HTML response differ? Can you introduce a timing delay that you can detect? These are detectable differences. They might not render in the page, but these are things that you can more or less look for. You can using string manipulation to extract data. That's what you're going to have to do, and you're going to combine those string manipulations with logic tricks to trigger those detectable differences. So we're going to show all of that. And as I warned on the evening, I like to have a couple of images in my live demos. I found this one on Pixabay, and it looks nice and cute, a kitty hugging some string. don't give your cat string if you if you have a cat. It might be adorable, but also what came up on Google Images and on Pixabay was nice and clean. But what came up on Google Images initially was a whole bunch of horror where little kitties can't digest a string. So I wouldn't give a dog chocolate. Don't give a kitten access to wool. They'll just go wild. That's just a bit of life advice. So when we're talking about string manipulation, a string in SQL is enclosed in single quotes, so we have a lovely example there. The string is A, B, C, D, E, F. The string means that it has several characters back to back, and they're enclosed in single quotes. The length function in MySQL, if you give it a string inside it, will return the number of characters in the specified string. So what we got here is A, B, C, D, E, F. That equates to 6. Fantastic. We can all figure out how that works. Let's jog on. Substring. Substring is a little bit more complicated, but hopefully it still makes sense. It takes 3 inputs. It takes the string that you're operating on. It takes an index where you're starting it, and it takes a number for the number of characters you're getting from the start. And yeah, that's how it works. It gets you a specific character in the string if you provide the length of 1 and a start index. So a couple of examples here. If we substring A, B, C, D, E, F again, and we give it number 1, 1, that gets the first character and gets 1 character. So we end up with A. If you do the same again, but you do 3, 1, you end up with C, and so on. So that's pretty good. Now that we know how to get a specific character, we're going to be able to later on use that in extraction. String compare. STRCMP is a function in MySQL where it takes one string and then another string and it compares them. Now, in most reasonable situations and most programming languages, what you're going to do if you have some sort of string comparison is you're going to compare string 1 to string 2, and it'll return false or true if they're the same. Now, this is not what the string compare function actually does. It returns 0 when the strings are the same, right? Because it's not the function it's trying to do. String compare AA bizarrely returns false. It returns 0, and in MySQL it is converting the 0 to false. So this is kind of a logic problem. This is not going to do what you expect it to do. It returns -1 if string 1 is alphabetically less than string 2. So here we have string compare AA. We've chucked in the equals. We're actually converting this to a true and false. And that kind of gets us the answer that we're wanting. If it's equal to 0, that actually means it's these strings are comparable. This equal has flipped it, so it becomes possible to use Boolean operations on it. So this becomes true, true. So that's the hack there that gets you to your thing. It returns -1 when string is alphabetically less. It returns 1 if string 1 is more than whatever. So I mean, effectively, it doesn't work the way you want it. Char Skills. The char function takes an ASCII number in it. It takes an integer in it, which represents a number in the ASCII table. That goes from, I think, 0 to 256, around about there. It's been a long time since my degree, folks, so don't bite my head off there. I would have to look that up. But Google ASCII table, and it will show you all the characters, printable, not printable, numbers, letters, whatever symbols are on your keyboard. And yeah, like I said, unprintable ones like new line, etc. So if you know what number it is in ASCII, you can use the char function to return that specific character. So number 97 is the letter A. If you select number char 97 equals to the string A, it returns true. So the important thing about this is that it returns like the actual string. So this is a string. This is a straight equals being used to compare it, and we get ourselves where we want to go. So in many respects, it can be more useful when you're doing data extraction. You can loop through the number from 0 to 256, or whatever the range is, and you'll get away with it. Char Skills true. The benefit here is that you can use it to do true and false Boolean implicitly. So equals works, less than works, greater than works. It allows optimization when doing data extraction, because you can sort of say, is the character that I'm looking for in the first half of the range of ASCII, or is it in the second half? You can use, is it greater than or less than a specific number somewhere in the middle of the range, and you'll get a Boolean true or false answer. It helps you write an automatic extraction tool which will do it really quickly. Now, we've done string manipulation. Those are all the functions we're going to use later, and we're going to move on to detectable differences. So, we kind of saw this if. I just skipped past it earlier. Some of you might have been freaking out about the use of the if a couple of slides ago. Well, I had to sort of logically split them, and I've stuck the if one here. If takes an expression which evaluates the true or false, and then you tell it something to do when the condition is true, or something to do when the condition is false. You can't run both of them. It's either true or false. So if you select 1, union select null, that's just going to return a table that has 1 and null. That's what I'm showing there. Select 1, union select if 1 is less than 2. That's the true condition, that's the false condition. So 1 is, of course, actually less than 2, unless I've been counting wrong all these years. So that's going to return the number 1. So if we run this, it's going to return 1. That's our answer there. Select 1, union select if 3 is less than 2. Now, unless I've been wrong, 3 is not less than 2, so it's going to run the false one, so you end up with the answer 2 down here. So it allows you to do something when one thing is true or another thing. Delaying skills. Now, in MySQL, more recent versions at least, there is the sleep function. So we've got sleep seconds. I'm not exactly sure how many years this has been hanging around, but it seems really useful for this function. It's not messing around with you. It's not asking for milliseconds or anything funky. It's asking for literal seconds. So if you run sleep 10, in this condition it's going to wait 10 seconds, because if 1 is less than 2, 1 is less than 2, the true condition is sleep for 10 seconds. You end up with a 10-second delay. If 3 is less than 2, well, that's not true, so we end up with the other condition. It comes back in 0 seconds. So you could use the if statement combined with the sleep statement to be able to trigger a delay that you can detect. So effectively, we're going to use the positive of a delay occurring to effectively be the time we know that we've found the right character. So, little sidebar, every SQL injection cheat sheet ever for MySQL pretty much says select benchmark, some number of repetitions, some mathematical function or whatever that will take some time. And that's, I think, because there didn't used to be a sleep function, obviously, or people making the guides just really liked the coolness of just forcing massive operations to happen to cause a delay. Computers are pretty quick these days, so you'd have to find something slightly more mathematically intense than just timesing 2020 by 2020, but the point's proved. You can trigger a delay, and I think an awful lot of cheat sheets, like I say, follow that. So maybe it's worth looking up the syntax for the back end you're targeting to see if maybe the situation's changed, because some of these tutorials for the cheat sheets are pretty old. So, demo gods be damned. Let's try and jump into the first demo, where I'm over here in my little virtual machine, and I'm gonna go through starting the Docker image for the app. So this just runs and port forwards the port 80 of the container into 8888, and yep, so that should be working in a couple of seconds. Docker PS, we've got it running, and yeah, we'll need that for. So I should be able to run this here. So I'm passing this through Burp Suite, and that was on super large, I think, because when I did the demo live, the people were pretty far away from the screen. So this is just our vulnerable app from before. Single quote in there gets you an error, but we've added in these blind SQL injection locations. So it's blind because the page doesn't return detectable results. So there wasn't like how that showed the table results before, or an error. You don't really get the things that we had in the first demos. What we got is a thing that just returns, and I would say I've breached the concept of blind SQL injection, because I've told you when it has one row and I've told you how many seconds it took. That's just for debugging purposes, because we're practicing our skills here. If you literally don't have this information, then it's pretty blind. But the functionality work like this: if we have tab, we have one row. If we have AAA, we have 0 rows. And it takes that sort of time. So there's no filtering or anything. This is just straight to injection. So this is my markdown version of my slides, really. And if I scroll through all the bits that you've already seen, we can get ourselves to data extraction. So the target URL is blind injecting into a string. From earlier exploits in the intro video, we see appdb database contains a table called users. As we discussed before, it's got 3 columns: ID, username, and password. We extract information using blind techniques. We're about to show combined with the intro materials content around determining table call names. So I don't need to go over how I found the database, how I found the table names, how I found the column names. That was all covered before, and I'm not going to waste my time. But you can effectively do what I'm going to do for data extraction, but applied to extracting the table names. And that's, I guess, a lesson to the reader here, or listener and viewer, actually. I'm so much more used to blogging than recording. So we are going to extract the admin user's password from the database. So we know that there's a users table, and we know that there's an admin account called admin. So first off, is the password longer than 5 characters? So this is a statement, union select null 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 from users where username is admin, and if the length of the password is greater than 5, sleep for 5 seconds. So if the length of the password is longer than 5 characters, we are going to see a 5-second delay. So if we run that, 1, 2, 3, 4, 5 haggises. So the result took 5 seconds. Like, wonderful. So that's us. It seems like a positive result to me. So if we go back here, is the password longer than 10 characters? So we're going to chuck all that in and chuck it again. Instantly returned in 0 seconds, so that to me looks like the password is less than 10 characters. So when I said scripting things, people have optimized SQL injection. They'll do little logic tricks like that. They'll start off with, is it bigger than that? Is it bigger than that? And then they'll sort of half their way. So you know it's between 5 and 7. So if you check, is it less than 7? What do we get there? That's sort of halfway between 5 and 10. It looks like we've got ourselves a 5 seconds delay again. There we go, 5 haggises. I don't know why I've decided haggises, but there we go, 5 haggises. So we grab ourselves this final one. Is the password length 6? So we know it's less than 7 and more than 5. Is it 6? It can only really be 5 haggises. So positive answer here. We know that the password length is exactly 6 characters long. So to do data extraction of a string, at least, we need to know how long the string is that we're targeting. So yes, it's 6 characters long. Then we need to go, how do you get the first character of the password, right? And just for free, I'm going to tell you that the password begins with S just because it speeds the demo along. So if we do union select null 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 from users where username is equal to admin, and if the substring of the password first character for 1 character long is A, sleep for 5 seconds. So if we try that, that should be our false result, because I've told you the password starts with S. So a 0 second delay. Fair enough. So you can sort of see how that works. If we put the same thing in again, and we make that S, it takes the 1, 2, 3 haggises, 4 haggises, a farm of haggises, 5 haggises. We got our thing. So we can determine that the first character is S, so we know that this is going to work. So you can also extract the same information using that char function that I spoke about, and that uses that syntax there. Union select null 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 from users where where username equals admin, and if the substring of password 11, give me the first character of the password, is equal to char 115, sleep for 5 seconds. So 115 will result in a 5 second delay here because that's the ASCII code for the letter S. It has its benefits, but because of the fact that I want to show Burp's intruder feature literally returning the thing, I wanted to go with the actual characters here, and it just, for time reasons as well. So getting the gold using Burp's Suite's Intruder. So Burp Suite's Intruder feature is available with a couple limitations in Burp community, but it's fine. So open Burp in Firefox, we've already done that. In Burp, start a temp project, in Firefox, set it to use the Burp as a proxy. I think I've done that, so I'm just going to verify this. So if I fire back in this probe again where we're looking for S, does the proxy stop it? Yes, it does. So that is our injection point there. I stopped it, so it is going through Burp. And when we get into Burp's proxy tab, I want to send that request to repeater. So the one that I just intercepted, I want to send to repeater. And effectively, you can paste this string when you have it. It'll be in the Git repository. It's the same string that we just saw, really. So I think that's where the first character is equal to S. Yep, so there it is. So if we literally just send that request, right-click, send that to repeater, there we go, send that to repeater, you would end up with this one. So we get ourselves the first character is equal to S. So I've already lined this up. This should work, beautifully. 1, 2, 3, 4, 5 haggises come back, right? And it says 5 seconds down there. So that's the same probe. Until this very recent version of Burp, if you mouse overed this part here where it was encoded, what you would get is you would get the decoded version. Unfortunately, they've just literally added a change recently, and I can't really see it, so I'm going to decode it and just show you what it is again. So union select null 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 from users where username is admin, and if substring password 11 equals S, sleep for 5. So that there's no trickery going on here. That's the same request that we had. So what we need to do is then right click and send this to the intruder feature, because intruder is where you can automatically sort of replay a request and modify wherever you put these markup points. So use the add, clear, auto to do things. So the places that I've marked up in the request is literally here, because to get the whole password we're going to have to enumerate through the start index between 1 and the number 6, because we know the length of the password is 6. So we're gonna inject in here, and the other one that we're going to change is this S here. So that's why in intruder, because we want to change which character we're comparing it to, we're essentially doing a brute force through a character set here and through the range of the 6 characters that we're looking for. So in intruder we need to have 2 places marked up. We need to have the 1 and we need to have the S marked up. So that's what we've done there. In the attack types, we want to have cluster bomb, I believe. That means you can have one set of payloads for this injection point and one set of payloads for this one, because they have different requirements. So in the payloads, we go into payload 1, and we're going to have number 1 to the number 6. That's the length of our password. We're going to do steps of 1, just because we need to enumerate to get each character. In payload position 2, all I've done, and I'll clear it, is I've added from the list A to Z lowercase. And the reason for this is I'm telling you that the password is all A to Z lowercase, and that's just for speed and ease and convenience. Obviously a real password would probably have mixed case and all those other characters, which is why sometimes using the char thing is better and more efficient. But in this case, I've just gone for what was quick, and it also helps us in the final screen to literally be able to decode the password without having to do ASCII decoding as well. So in options, I also want to make sure that I have one thread, and that's because if you're injecting things that cause time delays, you might have a bit of a problem if you're threading it. So for me, I've had mixed experiences with this in the past, so if I'm going to be doing this manually, I would encourage you to take one thread. So if we go ahead, at this point the doorbell went really loudly and my kids came home, but it was all a little bit like this, and so returning you to a regular scheduled program. If we go ahead and start the attack and just let it run, then what you're going to get is the single thread. The first one takes a long time because it actually replays the first payload we gave it, which was the positive result. So the first one here, request 0, is always the original request. So because that first character of the password was S, what it does is it takes 5 seconds, and you'll sort of see why I didn't make it the whole character set, etc., because this could take a little while. Also why I didn't make it a really long password, on account of the fact that this would take forever. I didn't want it to happen live. I've just about treaded enough water. Come on, boop-de-doo. Right, so now that we've got this finished, we need to filter down on the results. So first off, add the column here, and you say response received, because that gives you the number of seconds. And as you can see, I wasn't lying. Request 0 was a positive case, and it had a response of 5 seconds essentially, because of the timing delay. So if we take that, throw away request 0, because in our case, that's we know what that one was. That's the baseline request. If we select all the other ones, I'm just doing shift and I'm doing page down here. If we throw away all these negative results because they return too quickly to be positive, delete the selected items. What we've ended up with now is just 1, 2, 3, 4, 5, 6 of them. You can probably have a guess that this is going to say the word secure. If we sort by payload position 1, so that's position 1, the first payload position was 1, 2, 3, 4, 5, 6, because we incremented our numbers from 1 to 6, and then we get our characters here. So the actual answer is secure. So I hope that came across okay. So when I did it live, it worked well. Otherwise, I was literally just going to go, it works, guys. Like, it honestly works. In case that didn't work. But fortunately, we've managed to survive. So to recap what happened in there. First off, we had to find the length of the string that we wanted to extract. In this case, we used the length function, and we were giving it the password of the user account with the username admin. We looped through each character in that string using substring, so that was what intruder did. It was iterating through this start location between 1 and the number 6, which was the length returned here. We triggered a delay when the character matches, so if substring string the character that we're looking for effectively and the location that we're at equals to A, sleep for 5. So we iterated through this number and we iterated through this location here for the A to Z, all lowercase, until we got our answers. And then we extracted the list of responses with long delays, threw away all the other ones, and reconstituted the data. So if you used that char function, you just have to have an extra hop. You'd still do the throw away the characters that weren't valid. You just then have to write down each of the numbers and then look them up in the ASCII table or whatever to get it back. So fortunately, that's data extraction when you're doing it effectively in the blind. So is anyone for web shells? I love me a web shell. Got one recently on a test because a colleague went, we have a web shell here. It's a little bit hard to exploit. I don't really have the time to fully do it. I mean, we had command execution, we could prove it, but can you get on the system? And the guy gave me an open goal of a web shell to play with. I converted it from command execution in a tricky fashion to a web shell and had a lovely test. Customer was more than happy because they got the onward findings. So that's kind of what we're looking for. A web shell means that you can control server-side code which can pass commands through to the operating system. So we would do this when the database backend doesn't easily or doesn't support at all executing OS commands, and MySQL is in the camp of I think you can make it execute OS commands, but it requires a few extra hops, so web shell is probably easier. So our target is Apache using PHP, so we'd be having to upload a PHP web shell, which we'll show later, and you literally tailor the web shell that you're looking for based on the technology that you've seen. If it's .NET and IIS, you're going to try classic ASP or ASPX, and you just Google it. You basically find out what the technology is. If it was Flask, if it was anything like that, you go ahead and you try and find some way of doing it. So without further ado, we're going to start jumping into this. So what are we going to try and do? If you Google PHP web shell one-liner, and I've missed a double quote there and I feel tremendously bad about that, but whatever, we're power on. If you Google that, you're going to get this one here, which is very, very simple, and I think the credit has gone into the original author's work, is in the markdown, not in this slide, I guess for space, because it didn't want to mess it up with a URL. But anyway, it's quite a simple command, and we'll show it in the demo in a minute what it means. We'll see this later. That's what we're trying to do. How are we going to do it? The syntax is in MySQL is into out file, so quite simple. Whatever select or union select statement you've got, then you're going to go into out file is the new keywords, and then you have to know the location that you're going to write the file. So it needs to be the web root folder. That's the main thing here. It needs to be the web root folder. For it to be a web shell, what you need to do is you need to get it to save a file that you can control inside the web root, because typically that folder will be that folder will definitely be requestable via a URL later. So if you're able to only write files outside the web root, chances are you can't find a way of triggering the code, although it's not game over. It's just much, much harder. So we're going to show the easier case there. We're going to write into the web root folder. So this is where I went, demo gods really, really be damned, and I even went, screw you guys, I'm going home, if this doesn't work. I did that live. So I did literally flip the bird at the demo gods, and it all went fine. So let's see how it goes. We've managed to get ourselves the data extraction that we showed earlier, and if you don't want to watch the video and hear me rambling, I've written it down in text what I did. Web shell. So MySQL by default now prevents insecure file reading and writing using this privilege here, secure file priv variable. So the only way to disable this is to alter the config of MySQL and restart the service. Obviously, in a production environment, you don't have that kind of control, and that's why it's actually a very good little security measure. Because I'm giving you these targets as Docker, we can use a bit of Docker magic to actually change that config. I decided not to give you a version of it where this was disabled so that you could learn about how this would be fixed if you were testing a client, as well as how your environment has to be set up if you need to do this yourself. So there's very good reasons for me doing that. What I'll say is on Ubuntu, on the latest version, the version of MySQL that comes out does not have a secure file priv set to anything other than like temp folder. So the chances are you're not going to be able to get anywhere. What we need to do is override that setting by echoing basically two equals, so an empty string, into the mysqld.conf. So we're going to show you how to do that. For those unfamiliar with Docker, we need to run docker ps. We get our name here. We go docker it for interaction. Sorry, docker exec minus it for interaction. We're going to give it affectionate whatever that is, /bin/bash, because that's the command we want to run, and that'll give us a shell. So number one, hey, we've got ourselves a shell. Number two, hey, we're root, so we're already raiding shells, but we're not even there, guys. We're literally just abusing our privileges in this location. So I'm going to paste this command in here where it echoes secure file priv as blank, and it's going to add it into the MySQL conf file. So if we cat that back, or tail it back, tail -n5, and we paste that in, it should be just about the last line. We screwed the demo gods and now we can't see it. Right, so there it is. For whatever reason, that wasn't... Oh yeah, of course it is. I broke the syntax. Copy and paste error, folks. Don't panic. Don't panic. I'm not going to run home. So secure file priv is the bottom line there. So that was a copy and pasty file. So what we need to do is also, because of the fact that I saved myself a bit of time and I used some Legends Docker image to build the lamp stack, I've literally done no config inside of it. What they've got is they've started MySQLD as MySQLD safe, which is actually pretty damn good. It's great for production environments. It essentially means that if the MySQL service stops for any reason, it comes back up. And because we actually want to apply a change, it's not going to apply until we kill it and restart it. And I looked around for how best to kill it and went with the nuclear option of let's kill process ID number 24 and number 430. Is that right? So if we've killed those, if we kill them in the right order like I just did, the MySQL does not spring back without us telling it to, and then we want to restart the service by going /etc/init.d/mysql/start. That's going to bring it back up, and it's not actually going to start it with the MySQL safe. So if it does crash for whatever reason, now it's on you. The other thing that we need to do is allow the MySQL user to be able to access the web root. So if we look into it, it's owned by www.data, and the MySQL user is not in that group. So the most nuclear option, and this is my favorite, Chmod 777 is the nuclear approach to I don't care, just give everyone literally every privilege possible. So that means literally the anyone user can read, write, and execute into the var www HTML folder, as it should be in production, guys. You'd think nobody would ever do that, but the amount of times you pop a shell in a box and you find some kind of crazy privileges in the web root folder are going on, it's because it's easy. You want you'd think the situation would never come up that someone would turn off the secure file priv setting, that the situation would never come up that someone would insecurely set the var www HTML or the web root folder permissions. You'd think this would never come up, but so many applications will need a situation where, say, you want to have you've got a web application and you need to gather statistics from what's going on in the database. It's very easy to go, well, we'll give them a button that lets them generate a report live. They click the button, it runs some SQL, and it generates a report. And it's really, really easy to just go, well, we'll just make that report directly available in the web root, right? So you'll just run the report. The output is written by MySQL into a CSV file, and it lands inside the web root. So this is not an unusual situation. It's no longer the default. I'll be absolutely honest, it's no longer the default, so it's not going to be what you find every time, but it's also not an uncommon place to be. Maybe 777's a bit pessimistic, but in any case, we should have ourselves all we need to do to prove that we've now restarted the server and we've put all the privileges. So if we do show variables like secure file priv, so show variables like show file privs, and I think that's all we need to show. No, we don't. So at this point, the demo gods are laughing at me because it temporarily disabled my copy and paste abilities there. So I was just trying to do it manually, and if you can't paste, nothing ever works. So life lesson, and I think I put this out on Twitter consequently the same week that I've recorded this video, but way before. Don't type anything that you can literally paste. So anyway, now that that value says nothing, we're good to go. We know that our database is set up the correct way from the ls-la. We know that the file privilege is set up the same way. So now we can go back into the actual demo. So select into outfile is the syntax. So if we were to select one into outfile /temp, if I was to literally be able to copy that and paste that in, that's going to do what it says in the tin. So if we cat /temp/file, we've now written the word number 1 into that file. So that's exactly how we're going to exploit this. So here's our thing again. So I did say I'd credit the author. So it's /senti, and it's one of their gists there. And here we go. This is the syntax. If is set request command. So that gets from the URL of the request, it gets the parameter called CMD. If that is set, what it does is it echoes a pre-tag so that we get less formatting errors when reviewing this, and it sort of essentially takes the command that you've passed it, and it pipes it through the system function, and the system function just goes run that command that you've got and pipe the output straight back in, and it's going to land inside these pre-tags, and that's all it does. It's beautiful, simple. That's all it does. So now that you know how to save the file and you know what you're going to save, the final hurdle is to find the correct folder to write to, which I've said before in the video is webroot. Slight of hand where I didn't really explain what that was. For the uninitiated, webroot folder is where the web server starts to load content from. So if you're looking at it in your web browser, it's where the first / is at the end of the host and domain name. That last / in the sort of bit, that's gonna hit you. That's gonna be where there's gonna be a folder on disk that corresponds to that folder effectively. So how would you work out where that folder is on disk? I've sort of showed you var www.html. Well, it turns out that's the default on Ubuntu and Apache. So it's the location on disk is dependent on the HTTP server and the OS that you're on. Obviously, the path's going to be different for Apache on Windows, and various different flavors of Linux have historically got different webroot folders. So you try and learn the technology stack, so you can review the HTTP responses. You can look for the server header, which if we quickly jump into our repeater here, the server header here spits out quite happily everything. It goes Ubuntu there, it goes Apache and a version number, so we know exactly what we're playing for. We can straight up Google where the default webroot is for Apache on Ubuntu, and you'll get the answer var www.html. But like, you can pay attention to verbose error messages. If the site triggers error messages somewhere else, then most really verbose error messages will give you a line number of code and the full path to that file on disk. So pay attention to those full paths, they're really useful. And if you're targeting a product which has online support, you can just absolutely go Google around, find their documentation and look into it, because they might have deviated from the default for the HTTP server on whatever. And again, tutorials, look for tutorials to explain the target that you're looking into. So pretty much that's how we got the webroot folder. So our final payload here is union select null null null. Well, sorry, not null null null. Union select null null, and then in single quotes the what we're trying to write, which is the PHP, and we're going to go into outfile and we're going to give it var www shell.php. So if I copy that, come all the way back here, paste that, make sure there's a white space at the end of it. What do we get? Nothing untoward, 0 rows, 0 seconds. But if we go into did I just delete the wrong bit? Let's just refresh that. So that will cause some sort of error on the back end because it can't overwrite the same file. But if we go shell.php, what do we get? Whew. Blessed be the demo gods, we've pretty much got there. So that /n/n, they correspond to the two nulls. That's like, they end up with like sort of characters there. cmd equals id, so if you run that, whoo, and look at the HTML source. This is how I like to do my SQL injecting now. So the pre-tag is like exactly how we showed it in the one-liner. It sort of wraps it, and it means it's not going to interpret any HTML tags or anything like that. If we go ls-la, you can see the directory listings. So number one, at this point, you've got enough. You've established the fact that you've been able to write to the web root, and this would be another phone call to the customer. It's a case of, at this point, you're going to have a really high likelihood that you're going to have the box completely compromised at some point in the near future. For certain, you can do things like, you know, cat back the content.sql, right? So we can read the source code at this point. No bother at all. We can literally download the source code, and that means you can go researching for onward vulnerabilities. But yeah, so we're executing as a relatively low privilege user, I think. We're executing as www-data. That's a bit of a challenge. I'm not going to go into how you get a reverse shell from this, but my read would be PHP is installed in the box. You know that bash is installed in the box, because you can do wonderful things like which bash, right? So if you go which bash, it tells you the path on disk where the binary for the command bash is. So you've got options. At this point, you'd be able to Google reverse shell one-liners, and you'll be able to convert your PHP or web shell into an interactive shell yourselves. Lesson to the to the viewer here to go ahead and do that. Tell me how you get on. Happily to share the joy there on Twitter or whatever, as at Corner Pirate. So I think that's us. We've got ourselves to the end of the day. We've got ourselves through the demo. So back to the slides. Screw guys! Well, I didn't have to go home because I actually managed to make that work on the whole. So to recap, what did we do? Because of the default situation with MySQL on Ubuntu, at least for a couple of versions, disable secure file priv is what we had to do. Like I said, lots of websites actually do this for you. You couldn't influence it. If you just found an SQL injection, you wouldn't be able to influence it, so you wouldn't be able to convert the full loss of data in the database to getting a web shell anyway. But so that's why it's there. It's why it's a good feature. So you need to know the full path to the web root folder, and like I said, you look for the server headers, you do whatever you can to have a good guess, and then you just try a bunch of them. MySQL must run with privileges that can write to the web root folder, or the into-out file is going to have file permissions, and then you use into-out file to do it. And then finally, you access the shell by literally visiting that URL in your web browser, and you have a go at it. So I don't know if I'm going to end on the preventing SQL. Let's go for it. Let's prevent SQL injection again. This is exactly the same as the back 5 minutes of the first month's video, but let's just repeat it. So do not build SQL queries using string concatenation. That is always true. That is the primary defense. That means the one that actually really works all the time is to use prepared statements with parameterized queries. There's an example of one on the next slide. And when I do this live, I like to rant at this point. I go, if you are making an application and you're looking at this advice here to prevent SQL injection, and you look into the language and the framework that you're using, and it doesn't offer some form of prepared statement with parameterization, change the framework or the language that you're coding in, because there's probably going to be a relatively high risk posed by the application that you're using. You can't always live in a happy world where that is always possible, but I'd be making the case. I'd be going, guys, we need to use at least something that has a third-party library that does this, or we risk the problems of implementing it ourselves in whatever the language is, and then messing it up and it being bypassable in some sort of way. OWASP, Open Web Application Security Project, have some really good guides and some really good frameworks and tools that they have put out there that allow you to do this kind of stuff easily. They would be my go-to guys if your framework doesn't already support it. And you don't, it's like rolling your own crypto. You don't really want to get involved in it. You want to have some place that's publicly published it and it's been peer reviewed and tested. You don't want to do it yourself. Anyway, secondary defenses is reducing the risk. So assuming that you can't do the first one, or even if you can do the first one, you want to reduce the risk. So apply least privilege. And this month, at least privilege has a really good example. The principle of enabling only the permissions necessary for the database user. So number one, you can go, well, Corner Pirate, you literally turned off a setting for this to be you disabled a secure priv file setting to be able to make this work. That's not least privilege. You've given the user extra users, and I say you've given the user extra privileges. I say that's completely correct. But that's an exact example of why you use least privilege. Don't give the user the account the privilege unless it absolutely needs it. And of course, monitoring, alerting, and reacting is what you want to be doing pretty much for everything if you can afford it. So secondary defenses means reducing the risk. That applies even if the prepared statements are an option in your stack. You want to apply least privilege. Last month when I said it was kind of a bit wishy-washy, here we have an actual couple of concrete examples. For least privilege to be enacted, the database user shouldn't have the ability to write files to the web root. So literally the file permissions is extra privileges, but like if your application utterly needs that turned on, you have to turn it on, but try and limit it as far as possible. And the same with the secure file priv. If you don't need to disable it, leave it on. Right, so that's least privilege. Don't give users access that they don't need. And of course, monitoring, alerting, and reacting, those are things that you can always use and kind of rely on. Prepared statement example. So here we go, a little bit of PHP. The statement here is going to be created by the MySQLi library. It's going to prepare this. This is a string select star from people where ID equals to whatever. This would be user input. The insecure approach would be to just get the ID field from the post request and just drop it right in here. But what we do is here we are bind paramming it. I means integer, so it's expecting an integer data type. If the post parameter called ID has a string value, it is not going to run the query. It's going to go, that is not a valid integer. So that saves you a lot of hassle. You don't have to do a heck of a lot of input validation. No, well done. So that's how you do it. I and then S is for string. There's a couple of others, but effectively what we're saying is if there's more than one input point in the query that you're trying to run, you mark it up like how Burp Intruder had the sort of weird dollar symbol. You have a question mark. Wherever the question mark appears, you then mark up in this little string. If let's say there was two integers here, there'd be a question mark here where ID equals whatever and age is less than whatever. You'd have question mark there, and you'd have a question mark where the number for the age is. You'd have I for two I's, and then you'd do comma separated left to right, which parameter applies to which location. So if we add another comma and add the value for age over here, that's how that would work. So pretty simple stuff really. So you know when you're doing a security code review and you see this kind of stuff, you go SQL injections off the table. You go and try and find any location where they have a legacy ability to append strings, but you know, generally speaking, you find this in one location, you find it applied throughout. So where do we go from here? Follow me on Twitter @CornerPirate for more of these things. You know, if you want to thank me for the content or ask for a specific topic to be covered, I'm happy to be reached there. The demo targets and the recording from February is already there, and this is me literally live making the recording. So you're going to find by the time you're seeing this video, this video and everything, all the content from the demos here will have been chucked up. So that's literally the end. I'll leave you on the screen there with some references where you know, further information. If you want to just learn SQL, say you're completely new to SQL syntax, SQL Zoo will be the thing. When you're found in SQL injection, one of the main problems that you're going to have is figuring out how to use the techniques I've shown in these two videos between the different database backends, because Oracle and MS SQL and all the others effectively have different functions for doing different things. Like the delay is not, the sleep is not the same function, the delay is not introduced in the same way. So yeah, you got to be aware of that. The port swigger cheat sheet is actually new and it's up to date and it's really good. And the same thing is, I might have given you a vulnerable app here in PHP with MySQL. Well, PortSwigger have also put out their in their little academy, Web Security Academy, they've put out an SQL injection challenge. So I've been through this one myself. It's very good. It's up to date. It's modern. Go and give it a go. And all the stuff about preventing SQL injection, I literally just pretty much chopped it up from there. So all credit goes to OWASP.org. I made a couple of changes to make it relevant to my target, but really it's all about the OWASP love. So thanks for watching, and hope you've learned something. Okay?